Here is a graph, a sketch graph of the line y equals 5x squared plus 3x minus 4. And I've marked a point on the line there. And I want to work out the gradient of the tangent at that point. Well, to do that, if I could just zoom into this, let's put a box around there, zoom in. So then we've just got this little stretch of the line, magnified. There's the point X. If I chose another point on this line that's really, really close, let's say there, it almost looks like it's on top of it. But when we zoom in, it's a bit further away. If I work out the gradient of this chord here, it will be very, very close to the gradient of the tangent. And in fact, as these points get closer together, this one staying where it is and this one getting closer to it, we will find that the gradient of the chord, that's the gradient of the line that connects these 2 points, will be equal to the gradient of the tangent. And so what we're going to do is call this first point here, we'll call that x of how far it's gone across, no problem. And then up here, instead of calling this y, like this second point could be y, we'll say let y equal a function of x. Now our function of x is here, it's 5x squared plus 3x minus 4. So in terms of the coordinate that we get from here, the first one is x, the second ordinate that goes with that will be f of x. That is what comes out when we put x in here. Now we're going to add a tiny bit from this point here to this point here, because that's what we said, didn't we? We said we want this point to be as close to it as possible. So if we add a really small amount, and I'm talking like 0.00001, a really small amount, and we'll call it h. Then this point here, the value of the x coordinate will be x plus h. And then what comes out of that, of course, when we put x plus h in here in our function, we'll get whatever the function does to x plus h. Now we know how to work out the gradient of a line. So we'll say the gradient of this chord here, the gradient is going to equal the difference in y. So we've got whatever we get from f of x plus h minus the difference. So this is still the difference in y. So we've got f of x plus h minus f of x. And that's the change in y, or the difference in y. And we want to do that over the difference in x. So we've got x plus h. And we want to take away x. So we can work out this gradient. We'll tidy this up a little bit. So we've got f of x plus h minus f of x. And then on the bottom, we've got x take away x. So that's going to give us just h on the bottom of that. Now, this is a really interesting result. And we're going to use this to work out a gradient function. That is a function that's going to tell us the gradient at any point on this line. And we're going to show from first principles what we get, because actually the gradient, or the derivative, sometimes we say of this, of the function, which is represented by f dashed of x, the limit of this as h tends to 0, that is, as h gets smaller and smaller and smaller, we're going to get this result, f of x plus h minus f of x all over h. And whatever we get from that will be the gradient function. We can then put a value of x in this, and it will tell us what the gradient is at a given point. An exam question could be, given that y equals 5x squared plus 3x minus 4, find dy by dx from first principles. dy by dx is the gradient function that we get when we differentiate this function on the right hand side here. Sometimes we call it the derivative. Now the first thing I'm going to do is say let y equals f of x, because I'm more familiar with this terminology. And then the derivative, that is f dashed of x, the gradient function, is given by, as the limit of what we're going to write on the right hand side, h tends to 0. That is, h is getting smaller and smaller and smaller. Then we have f of x plus h minus f of x all over h. Remember, that gives us the gradient. I'm going to work out what f of x plus h is and then substitute that into this. So f of x plus h, what we're doing is we're taking x plus h as the input of this function, which at the moment is x. So everywhere we see the x, we're going to write x plus h. So I've got 5 x plus h, and that part is squared, plus 3 lots of x plus h minus 4. If I expand this bracket, I'm going to keep the 5 there for a moment, expand this, it's going to give me x squared plus 2xh plus h squared, plus, expand this bracket, 3x plus 3h, and there's the minus 4. And to finish up, I'm going to expand this by multiplying each term by 5. 5x squared plus 10xh plus 5h squared plus 3x plus 3h minus 4. I can't simplify that anymore at the moment, so I'm going to now substitute this f of x plus h into this up here. So f of x plus h minus f of x all over h is equal to, I was trying to line up my equal signs there, it's gone a bit wonky, but that's okay, is equal to all of this, so 5x squared plus 10xh plus 5h squared plus 3x plus 3h minus 4, all of that, minus the original function of f of x, because we said let y equals f of x, so we're going to take away all that. So that's minus 5x squared plus 3x minus 4. And that's all over h. And what we can see here is that some of these terms are being cancelled. So we've got 5x squared minus a 5x squared. So a neat line through there. We've got a 3x on this side and a minus 3x on that side, and minus 4 there, take away minus 4 there. Now if we look at this carefully, there's an h in each term on the numerator and an h on the denominator, so I'm going to take that out as a factor. So h, that's going to leave me with 10x for this term, it's going to leave me with 5h for this term, and it's going to leave me with plus 3 for this term. And that's still all over h. And now these two can cancel. Right, so what's my final result here? So f dashed of x, that's the derivative, equals, well, the limit of this as h tends to 0, we're going to write that result in a minute. We've got 10x plus 5h plus 3. Which as h gets smaller and smaller and smaller, as it tends to 0, this term becomes negligible. So all we're left with is 10x plus 3. And that's the result that we want. So how are the marks allocated for this question? There are 5 marks up for grabs. Well, I'm going to get 1 mark for the method. Writing this isn't enough, but using it like I've done here, that's going to get me my method mark. And actually writing in the right expansion of these different bits is going to get me a 2nd mark. And then the 3rd mark is going to come from getting the correct bit in brackets here, the 10x plus 5h plus 3. And then the next mark, the 4th mark, is going to come from making sure I divide by h like I've done here. And the final 1 mark, of course, is for referring to the limiting value of the derivative and then getting this answer at the bottom there. And that's how you get your 5 marks.